Hello and good morning to all of you. I hope all of you are doing well and all of you in good health. In today's class, we will discuss 8086 assembler directives. Assembler directives are basically directions that are given to the assembler which indicates how an operand or a section of program is to be processed. Assembler directives in 8086 do not represent program instructions and are not translated into machine code by the assembler. Hence, assembler directives are also called as pseudo operations. Now let us acquaint ourselves to some of the assembler directives 8086 microprocessor has. The first assembler directive that 8086 microprocessor has is called as segment. The segment directive is used in order to indicate the start of a logical segment. Again, I'll repeat it. The segment directive is used in order to indicate the start of a logical segment. Preceding the segment directive should be the name of the logical segment. For example, the statement code segment indicates the assembler the start of the logical segment called code. Now, the segment directive is used in conjunction with end-s directive in order to bracket a logical segment. Now, additional terms are often used in conjunction with this directive, that is segment directive, in order to indicate some special way in which you want the assembler to treat that particular segment. For an example, if you want to keep a segment public, we use additional term public. Now the next directive that we have is called as end-s. As said, this directive is used with the name of the segment in order to indicate the end of a logical segment. So end-s directive is used in order to mark the end of a logical segment. For an example, so if we have created a logical segment by the name code, so here we have a logical segment by the name code. Now if you want to end that particular segment, so we have to write code end s, so it will end that particular logical segment. So every logical segment that we create has to be terminated with the help of end segment directive. Now the next directive that we have is called as end. Now the end directive is used in order to mark the end of a program module. So the end directive is put after the last statement of the program to tell the assembler that this is the end of the program module. The assembler directive, the assembler will ignore any statement after end directive. So this is very important. So end directive is put at the end of the program model in order program module in order to mark the end of the program, and the assembler will ignore any statement that are placed after the end directive. Now, one of the important uh, considerations in case of end directive is that a carriage return is required after the end directive in order to ensure that the end directive is capable of providing necessary information to the assembler. Again, I'll repeat it. A carriage return is required after the end directive or after the placement of the end directive in the program module. Now, the next assembler directive that we have is called as assume. Now, the assume directive is used to tell the assembler the name of the logical segment it should use for a specified segment. Again, I'll repeat it. The assume directive is used to tell the assembler the name of the logical segment it should use for a specified segment. For an example, the statement assume cs colon code, for example, tells the assembler that instruction for a program are in a logical segment by the name code. So here, if we create a segment by the name code, then we will tell the assembler that the instruction for a program are at logical segment name code. Likewise, if we want to tell the assembler about the data, so what we need to write is the statement assume ds colon data tells the assembler that for any program instruction or program data which refers to the data segment, it should use the logical segment called data. So here it should use data logical segment in order to refer to any data. So now likewise we have another assembler directive that is called as db. db basically stands for define byte. Now the db directive is used to declare a byte type variable. Again, I'll repeat it. db directive is used in order to declare a byte type variable or a set aside one or more storage location of a type byte in the memory. So for simplicity, just remember that db directive is used in order to declare a byte type variable. Now there are different ways in which you can use db. Now here what I have is I have a variable by the name prices. Prices db 49h, 98h and 29h. So here it declares an array that is named as prices, and 3 bytes are allocated to this particular array, and it will initialize the locations in the array prices with the value 49h, 98h and 29h. So this is the way how db is used in this particular instance. So here we are creating an array by the name prices, which is allocated 3 bytes of memory space, and the allocated memory spaces are initialized with 49h, 98h and 29h. Now likewise in the second instance, names db Thomas. So here it declares an array of 6 bytes. So THOMAS has 6 bytes in it. So it declares an array of 6 bytes and initializes the array with the ASCII code of the letters in THOMAS. So it will declare an array by the names, which is of 6 byte in size, and then it will initialize the allocated spaces with the ASCII code of the letters THOMAS. Now, the first two examples are the ways how or reflects the way how DB can be used in order to allocate memory to an array. So in the first case, we have an array of size 3. In the latter case, we have an array of size 6. Now, third case, temp db100 duplicated with. So here we do not have a value with which the allocated memory is duplicated with. So it sets aside 100 bytes of storage in memory. So here we have 100 bytes of memory being allocated to the variable that is called as temp. So here temp will be pointing to the base address of the allocated 100 bytes, but it leaves the 100 bytes uninitialized. So in this case, it allocates 100 bytes of memory location to a variable called as temp, but it will leave the 100 bytes uninitialized because we have not initialized temp with any notable value. Now, in the fourth case, pressure db 20h duplicated with 0. So here what does it do? It sets aside 20h bytes of storage in memory. So it will set aside 20h bytes of storage in memory, and pressure will be pointing to the first byte of the allocated address space, and here the allocated memory space is duplicated with value 0. So here it will put 0 in all the 20h locations. So in the third and the fourth case, in the third case, 100 bytes are allocated to the variable that is called as temp, but the allocated memory space is not initialized with any value. But in the fourth case, we are allocating 20h number of bytes to the variable called as pressure, and the allocated memory space is duplicated with value 0. So these are the possible ways in which you can use DB in order to allocate memory bytes to a variable. So DB, again I'll repeat it, DB directive is used in order to declare a byte type variable. Now likewise we have DW. Now DW directive is used to tell the assembler to define a variable of type word. So here we will allocate 2 bytes to a variable. So again I'll repeat it, the DW directive is used to tell the assembler to define a variable of type word. Now here we have an example. So we have few examples. So the statement multiplier DW433AH. So for an example, it declares a variable of type word by the name multiplier and initializes the allocated memory space with 433AH. Now likewise we have second example, words DW1234H 3456H. So here it will allocate 4 bytes of memory to an array. So it declares an array of two words and initialize them with the specified values. So here we have an array or by the name words, and there are there are 4 bytes of memory allocated to this particular array that is equivalent to the size of two words. So it declares an array of two words and initializes them with the specified value. Now, likewise, the third example, storage DW 100 DUP 0. So here it reserves an array of 100 words of memory and initializes all the 100 words with 0. So here this is as compared to that of DW can be used in order to allocate. We have learned that DW can be used in order to allocate memory to an array. So here in this case, storage DW 100 duplicated with 0 basically means we are allocating memory to an array which is equivalent to that of 100 words, and the allocated memory space is being initialized with 0. Now likewise, storage DW 100 duplicated with, so here it will reserve 100 words of storage to an array by the name storage, or it will allocate 100 words of memory to a array by the name storage, but here in this situation it will leave the array uninitialized. So the the third and the fourth examples are same as that of DB, but here instead of uh, there we were allocating bytes, here we'll be allocating word. So these are the different ways in which we can use DW. Now likewise we have DD. Now the DD directive is used to declare a variable of type double word. So double word basically refers to, so word allocates 2 bytes of memory, double word allocates 4 bytes of memory. So the statement, so here we have an example, the statement array dd, so 25629261h. So here an array is a variable of type double word which is allocated 4 bytes of memory space, and the allocated memory space is assigned with value 25629261h. So here the statement array dd 25629261h, for example, will define a double word by the named array and initialize the double word with the specified value when the program is loaded into the memory to be run. So this is the way how dd can be used. Now here it is to be remembered, the lower word, that is 9261H, will be put in a lower address space, and 2562 will be put onto the higher address space. So lower byte in the lower address space and higher byte in the higher address space, as we have learned in case of 8085 microprocessor. That is the way how the memory access takes place. Now the next directive that we have is called as DQ. So DQ basically stands for defined quad word. So quad word basically refers to 4 words. So the DQ directive is used to tell the assembler to declare a variable of 4 words in length. So again I'll repeat it. DQ is used in order to tell the assembler to declare a variable of 4 words in length. So here we have an example. The statement big number DQ 243598740192 A9 2BH, for an example, we declare a variable by the name big number and initialize the 4 words set aside with the specified number when the program is loaded into the memory to be run. So this is the way how DQ basically works. Now DT. So DT stands for defined 10 bytes. So the DT directive is used to tell the assembler to declare a variable which is 10 bytes in length. Again, here we have an example. So this is the statement packed underscore BCD DT 11223344556677889900 will declare an array named or a variable named packed underscore BCD, which is 10 bytes in length, and it will initialize the 10 bytes with the value that is specified when the program is loaded into the memory to be run. So these are basically the different ways in which you can use directives in order to declare a variable. So we have learned about db, dw, dd, dq, and dt. Now we have another assembly directive that is called as dd. So dd basically stands for define double word. So this indicates this directive is used in order to declare a variable of type double word, or restore memory locations can be accessed as uh, double word. So these are the possible ways in which you can uh, allocate memory to a variable using the various assembly directives. So in the next class, we will continue with the rest of the assembly directives. Thank you very much. Have a good day.